vertex. I'm going to count up because the parabola is pointing up. These are the numbers that I'm going to count up. So I'm going over 1 and up 1, and I'm going to put a dot. Then from that second dot, I'm going to go 1 over and 3 up, and I'm going to put a second dot. Then from that dot, I'm going to go 1 over, and I'm going to go 5 up. If I had room, I would go 1 over and then 7 up, and then I would go 1 over and 9 up, and if I had room, I would keep going. I'm going to go back to the vertex, and I'm going to do the same thing on the other side. So I'm going to go 1 to the left and 1 up. 1 to the left and 3 up. 1 to the left and 5 up. I think I missed that last one. Yes, I did. So when I say the width is 1, 3, 5, what that is the amount we're counting up. We're always going to count 1 to the left and the right. And why? Because the difference in the x coordinates is always 1. The difference in the y coordinates is the odd numbers. If the direction was down, I wouldn't have counted up. I would have counted down. That's the only difference. That's it. That's graphing a parabola. Join these points in a nice little parabolic shape. Make sure you put your arrows on the end. Done. Graphing a parabola. Always from the last point. So we call this 135 standard width, and I'll show you in a second what happens when there's a number in front. It's called the standard width 135 dot 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 is the odd numbers. Okay, so that was a pretty easy parabola. Let's look at one of the most complicated. Here we've got a negative, we've got a 2, we've got 2 values for the vertex. This is about as hard as it's going to get. Lots of stuff in here. The vertex, take the number in brackets, change the sign. Take the number outside the brackets, leave it alone. What is the vertex? Offer of -4, -2. Do you confirm? What is the direction of this parabola? How do we know it's down? Because the direction is down. I start with the standard width, which is 135 dot dot dot. I always start with the standard width. And all I'm going to do is multiply by whatever the a value is in front of that parabola. So I'm going to multiply by the width. Because I have an a value of 2 for this one, I'm not going to have 135. I'm going to have 1 times 2 is 2. 6, oh, I just told you the answer. Shoot. 3 times 2 is? 5 times 2 is? Dot, dot, dot. That's the only thing that's different is when you have a number in front right there, we multiply what's called the standard width by the value of a. If you go way back a couple of classes, remember I talked to you about vertical stretches and compressions and a giant yanking on you and a giant sitting? That's what this is doing, is it's stretching it up vertically twice the distance. It's taking it and it's yanking on it. Joe? The negative is just the direction. Correct. The width is that a value without the negative. So I start with the vertex. So I'm going to go to -4, -2. Am I going to count up or down? I'm going to count down, and this is the amount I'm going to count down. So I'm going over 1, down 2 this time. And I do the left and right at the same time because I get lazy and don't want to go all the way back and redo it. Then I'm going to count over 1 and down 6 on the left and the right. If I had room, then I would go over 1 and down 10 if I had room. Join these in a parabolic curve, and you should see we have a skinny parabola that is twice the stretch of the one before. I'm just going to go back and just add a few notes about the width, so when you look back, you can see what we talked about. What I did from the vertex is I counted over 1, up 1 in this very first one. Then I counted over 1 and up 3. Then I counted over 1 and up 5. And if I had room, I would have kept going, and then I came back and did the same thing on the left-hand side. What I did in this one, because of the a value of 2, is I still went over 1, but I went up 2. So 1 times 2 is 2. Then I went over 1 and up 6. Then if I went down, but whatever, you'll figure that out. If I had room, I would have gone over 1 and I would have gone 10. And that all just comes from the value of a at the front of the equation.
So after you did over 1, the second time, then
So down 2, down 6, and I would have gone down 10, but I ran out of space. How are we feeling so far? Okay, let's look when I have a 1/2. Well, we already know what this is going to do to the parabola. What is it going to do if I have a fraction in front? It's going to make it wider, so keep that idea in mind. Vertex, take a number in brackets, change the sign. Take a number outside the brackets, leave it alone. What is the vertex? The direction up or down? How do you know? Standard width is 135, dot, 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 but I'm going to multiply it by the A value. So 1 times 1/2 is 1/2. 3 times 1/2, 3 on 2. 5 times 1/2. Now it starts to fall apart. 5 times 1/2, 5 halves. If you're not into the fractions, you can show this in decimals. So I know that the first one is 0.5. What's the next fraction in decimal? 1.5. And what's the next fraction in decimal? 2.5, dot, dot, dot. So fraction, decimal, whatever your brain likes better in this one. Questions so far? Vertex first, so -1, -1. Now I'm going to zoom in so you can really see what I'm doing when I count this one. Am I going to count up or am I going to count down? Up. I'm always going 1 over, it's the amount up and down that's going to change. So I'm going to go over 1, I'm going to go up 1/2 on the left and the right. Can you see I'm halfway in that box? Correct, because it's symmetric because of the axis of symmetry. Now I'm going to go over 1, up 1.5. And I'll do the same on the other side. Now I'm going to go over 1, up 2.5. Can you see I ended up back in the middle of a box there? Well, I have room, but I don't have a next number. But if it went 0.5 and 1.5 and 2.5, what does the next one have to be? So let's do another one just because we have room. Over 1, up 3.5. Drawing this in a parabolic shape. Don't forget your arrows on either side, and there's your first wide parabola. Isn't this kind of cool? Like, seriously, show this to an Essentials kid, they'll cry. Questions so far? Do you understand why I call this method vertex with direction? Because it's the 3 pieces of information we need. Take the number of brackets, change the sign. Take the number outside the brackets, leave it alone. Crap. What's wrong with this one? This is in standard form. We don't need it in standard form. We need it in vertex form. How do we change it to vertex form? Complete the square, what we did yesterday. So you guys walk me through it. Okay, let's just talk about what we did there. So what was step 1 and why did we do that? Because there's a common factor, and more specifically, there's an A value of 2, and I need that width outside to figure out what the width is. Why did this turn to a 2? Because it would have been 4 divided by 2. So if you need to write to see the division, then write it underneath. There's nothing wrong with that. Okay, fill in the space. Where did +1 come from? How do I balance my +1? Except I got to multiply by that 2 on the outside. Okie doke. Where did the minus 1 come from? Where did the 3 come from? Could you have looked at this and realized the vertex was 1, 3? That's why we need to complete the square, because the only way to get the vertex is in this form. Vertex, therefore, is 1, 3. Direction. Standard width is 1, 3, 5, but we're going to abort that because of the 2, which would make it go ahead and graph it. Why is it so skinny? Because that's what people do all the time. Actually, I can't lie, I did that by mistake. I can't even fake that one. Better if it's over here? Why is it so skinny? Because what's 2? The A value, the width is 2, so it becomes skinnier. Imagine, ladies, if we could eat twice as much and become twice as skinny. That would be lovely. Questions so far? Yes, that's why I crossed out the purple one. Mm-hmm. What do you mean by the line? Yeah. So when I count, I go 1 to the right, up 2, and then I go 1 to the left, up 2. And then I go 1 to the right, up 6, 1 to the left, up 6. So I just do those at the same time. So left, right, and then up. How are we doing so far? Method number 2. The only time we use method number 2 is when we're given a question in vertex form. Not vertex form, intercept form. And this one requires different information. We use the x-intercepts, the axis of symmetry, and then we use the axis of symmetry to find the vertex. How many ways does solve a quadratic? There are 4. What are the 4 methods? Factoring. Well, we're going to use factoring because this is already factored for us. That's why to find the x-intercepts, we're just going to split and solve. So the x-intercepts, when we split, are x equals -3 and x equals 1. And I'm just going to write those as x-intercepts, so -3, 0, 1, and 0. And so I'm going to plot those first. They have to be right on the x-axis because they're x-intercepts. Now the problem is that by itself isn't enough because I can't tell where the parabola is. Does it point up or does it point down? What's going on here? So I'm going to use some more information. The axis of symmetry is going to tell me the x-coordinate of the vertex because we know those are related. And I can use the x-intercepts to find the axis of symmetry by using the fact it's symmetric. If a parabola is symmetric, what do we know about the two sides? They're equal. That means the vertex has to be halfway between these. How do you find a point that is halfway between two other points? What up there from last year might talk about a point that is halfway between two other points? Yes? Midpoint. So that's what we're going to do, is just calculate the midpoint of the x-intercepts. Midpoint is where we take the two numbers, add them together, and divide by 2. So what I'm going is halfway between -3 and +1. What's -3 plus 1? And what's -2 divided by 2? Now, I'm not going to draw it, but I'm going to just show you on mine. Is now we know somewhere along this line is the vertex. The problem is I don't know how low it is. I know it doesn't go up because I know this isn't a down parabola. But I don't know, is it -1, -2? Is it -1, -5? Is it -1, -7? We don't know how far it goes down. To find the y coordinate, I'm going to substitute the axis of symmetry into the original equation and solve for y. I'm going to take that value of x, I'm going to plug it in for the two x's, I'm going to simplify to find y. So I'm going back to the original equation. I'm going to take x out and put in -1. So I just replaced x, put in the axis of symmetry. Now I'm going to do some BEDMAS. Brackets are first. So the first set of brackets, I have -1 plus 3. 2. And the second bracket, I have -1, -1. And then in BEDMAS, the multiplication comes next. So 2 times -2, -4. Still with me? What that is that's our min or our max, because that's got to be at the same point of the axis of symmetry. I'm going to take the axis of symmetry and the min max, and I'm going to shove them together to get the vertex.
So the -1 is the min and -4 is the min?
-1 is the axis of symmetry, -4 is the min. Questions so far? The +3 from the question right here. Now I'm going to plot the vertex, so -1, -4. And once I have the two intercepts and the vertex, I can draw the parabola just by coming through the x-intercept, down to the vertex, back up, and put the arrows. You don't have to with this method. This doesn't include the width at all. I hate this method. It's way more work. I never use it, but if the question's in this form, it's the easier way to do it. I would FOIL this out and then complete the square and then do it the other method because I hate this method. But if you don't want to do all that work, you can do this method.
So is it like the last unit where we have to know all?
No, with graphing, it's totally up to you.
Okay, sweet.
But we'll practice this just in case someone likes it better. Sketch your graph of -2, x plus 2, x minus 4. X-intercepts we split and solve, so I'm going to split between the 3 pieces for this one. So in theory, what I have is -2 equals 0, x plus 2 equals 0, which we know gives me -2, and x minus 4 equals 0, which gives me x equal to 4. Can -2 ever equal 0? That makes no mathematical sense, so I ignore it. So in essence, ignore the width of that negative. It has nothing to do with the x-intercepts. What is the negative telling us? The direction. What is the 2 telling us? The width. It's regardless of what you're doing here. All you need are the 2 binomials with x. So my x-intercepts are -2, 0, and 4, 0. Axis of symmetry is just halfway between these two x-intercepts. So if you can look and see what halfway is, you don't need to do a calculation. I'm doing the calculation just so later you see what we've done. All we're going to do is add them together and divide by 2. It's just finding the average. -2 plus 4 is 2, and 2 divided by 2 is, so I have an axis of symmetry at x equal to 1. So I know somewhere along this line is my vertex. The problem is I don't know where it is. I know it's got to be above the x-axis. How do I know that? How do I know that this is a down-facing parabola? because of the negative up front. The problem is I don't know how high it is. I don't know if the vertex is down here, up here, way up here. I have no idea. That's why I need this last step. Last step is we go back to the original question. We take out x, we put in the value of the axis of symmetry. We bed mass it, so we have to do the brackets first. 1 plus 2. 1 minus 4. And the last step is just multiplying all those together. So negative 2 times 3, negative 6, negative 6 times negative 3. Ooh, I heard 18 and I heard 12 at the same time. Questions on that? All I'm doing is taking these two values, slapping them together to get the vertex. Okay, 2, and I got to fake it here because 18 is off my grid. So we'll just pretend that's at 18. And here's a really stretched out parabola. Questions so far? Ugh. Ugh. Yeah, we don't have it in the right form. I would never use this method for this kind of question. I would complete the square and use the first method. But I want to show you on how to use this method in case you like it better. But just note, it's the longer way. It's not how I would do this. But let's practice. X-intercepts means we need to factor because we need to be able to split and solve. So we need 0 on one side. And then we need product to sum factoring. So factors that multiply to give us 24, add or subtract to give us negative 10. I heard the offer of negative 6, negative 4. Looking for confirmation. Split and solve. I always like to write them as intercepts so that it's really clear what we're doing with them because they kind of look like axes of symmetry when we leave them like that. So I like to write them as coordinate points so my brain sees I got to plot these points. Well, if one is 4 and one is 6, what does the axis of symmetry have to be? What's halfway between 4 and 6? Has to be equal to 5. And if you want to do the same calculation as 4, you're just adding them together and dividing by 2. So 4 plus 6 is 10. 10 divided by 2 is 5. To finish it off, you can go back to the original or you can go back to your factored form. It doesn't matter. It will give you the same number. Do you want to go back to the original or back to factored? Okay, let's go to factored form. So I'm just going to take out the x and put in 5. 5 minus 6. 5 minus 4. Negative 1 times 1. What does that make the vertex? Here's our little tiny parabola. Don't forget your arrows. You could have. Yeah, you could have counted 3 up from there. It's fine. Yep. Just repeating, I would never do this method because I like completing the square. I'm really good at it and I'm fast at it and I can do it faster than I can factor. If you like this method, there's nothing wrong with that. You can pick and choose. If it's in factored form, I probably would use this method because it's a little bit faster, but I would probably complete the square. Completely up to you. Ugh, just dropped my pen. Worksheets. We've done Mickey. We've done the table. Now we're on Mulan.